Hello. When the last video cut off, we had just proven that ABCD is a parallelogram and a rhombus. Now, I am now going to check and see if ABCD is also a rectangle. If it is a rectangle, it will also be a square. I personally am going to use the congruent diagonals method to prove this. So, I look at the distance of AC, I use the distance formula, and I plug in the coordinates into the formula and get 2 square root 10. I find the distance of BD, the other diagonal. I also get 2 square root 10. Therefore, the diagonals are congruent, so ABCD is a rectangle. Because ABCD is a parallelogram, a rhombus, and a rectangle, it is also a square. Therefore, the most specific classification of this quadrilateral would be to say that it is a square. Now we're going to go through and classify these different shapes. This first one is a parallelogram because I can see that one angle, the one marked 44 degrees, is supplementary to both its adjacent angles. This next shape is a rhombus. It is a parallelogram because the diagonals bisect each other. So we have satisfied the prove it to be a parallelogram. Then we see that the diagonals also meet at 90-degree angles. And in a rhombus, the diagonals are perpendicular. Therefore, the shape is a rhombus. It is not necessarily a square. Even though it looks like a square, we don't have enough information to say it is a square. This next shape is a parallelogram. The diagonals bisect each other, therefore it's a parallelogram. It is not a rectangle because the diagonals are not marked to be congruent. If all of the diagonals had been marked with one tick, we could say it's a rectangle, but because it was not, we must assume it's only a parallelogram. And this last shape is a quadrilateral. We don't know if this is even a parallelogram, even though the diagonals are perpendicular, so I can't even say that it's a rhombus. Let's take a look at some more practice. A parallelogram has two pairs of adjacent sides that are congruent. Well, we've satisfied that it's a parallelogram, and we've said that the adjacent sides are congruent, therefore it must be a rhombus. A parallelogram's diagonals form 8 congruent angles at the vertices. This must be a square. All of these angles that they've described, these 8 congruent angles, must be 45 degrees because we've taken 360 and divided it by 8, which makes 45. So all of the big angles are congruent 90-degree angles, making the shape a rectangle. The diagonals must also intersect at 90 degrees, making the shape a rhombus. And because it's both a quadrilateral, a rectangle, a parallelogram, and a rhombus, it must be a square. A parallelogram has perpendicular diagonals and angle measurements of 45, 135, 45, and 135. The perpendicular diagonals make the shape a rhombus. It is not a square or a rectangle because the angles are not all congruent 90-degree angles. A parallelogram has perpendicular and congruent diagonals. This shape is a rhombus because the diagonals are perpendicular. It is a rectangle because the diagonals are congruent. Therefore, because it is a parallelogram that is also a rhombus and a rectangle, its best and most specific classification makes it a square. A parallelogram has perpendicular diagonals and angle measures that are all 90 degrees. The diagonals are perpendicular, so it is a rhombus. All angles measure 90 degrees, so it's a rectangle. Because it's both a rhombus and a rectangle, it can be best classified as a square. A parallelogram has congruent diagonals. Congruent diagonals make the quadrilateral a rectangle. Now looking at these next diagrams, I see that I have a parallelogram where opposite sides are parallel and a diagonal bisects the angle. Because one diagonal bisects a pair of opposite sides, that must be a rhombus. This one I know it's cut off a little bit, but this one I see I have opposite sides are parallel. All we know is that it's a parallelogram because the opposite sides are parallel. We have no other information to go off of, so we can only classify it as a parallelogram. This next picture, these next two examples, I want you guys to try on your own. Come back, show it to me in class, and I will give you some extra points on your homework. Now let's take a look at some algebraic examples. To make this into a rhombus, I have to prove that the diagonal bisects the angle. I can do that by setting those two phrases equal to one another and solving for x. So x must be 1. I want you guys to do the second example. And these two. All right, that's it. Thank you all very much for listening. I will be checking your notes in class, and have a great weekend.